Welcome to the discussion on the new features of Java from the language perspective. I am Manoj and I work at IBM leading the Java compiler effort for Eclipse. I am also honored to represent Eclipse Foundation in the expert group for the Java specification requests from the last few releases onwards. Traditionally, Eclipse has always been associated with Java, and as you all already know, Eclipse has its own Java compiler. Eclipse compiler for Java or ECJ. Hence, any change in the Java language naturally requires a change in our compiler. Primary focus nowadays for us is to get the new features of Java implemented in Eclipse. Specifically in the stock, we are going to look at Java 14 and 15 versions, released in March and September of this year, respectively, with an occasional glimpse of what's going to happen in Java 16 and beyond.
First, let's understand what it means when we say that the Java language has a new feature. Essentially, it means at most two documents have changed, the Java language specification and or the Java virtual machine specification. From a Java language compiler's point of view, it means two things. Number one, the compiler has to convert any Java which conforms to the Java language specification to an class that conforms to the JVM spec. And two, the compiler needs to flag the errors for an Java that does not obey the rules. So we'll touch upon these different aspects when we discuss the features, seeing some good programs as well as some incorrect programs so that we understand the features better. Given the fact that Java is on a 6-month release cycle, many new features have come up recently, from the famed Lambda expressions of not so distant past to patterns that's going to come in the near future. We are living in exciting times if we are using Java. So instead of touching on all of them, let's look at some of them in some detail. Before we start discussing the features, just a word about the preview features. Due to the 6-month release cycle of Java, it was not always possible to get the feedback for a new feature. Hence, the concept of preview features was introduced. This is nothing but different iterations for a new feature. A new feature might have to go through a few preview stages before it becomes standard. Typically, feedback is complete by a couple of iterations, and by the third one, the feature becomes a standard one. Now, there is no hard and fast rule that it should take only 2 iterations, but that's generally what's found in practice. From a user's perspective, if you want to use the preview feature, you should enable it using the dash dash enable dash preview option. One important point to note here is that you need to provide that option both at the compile time as well as at the runtime. The features which we are going to discuss here are in different stages. Some have become standard already, some are still in a particular preview stage. We'll just mention it as we go forward and as we take up these features one by one. So what's new? There are quite a lot of features which are coming nowadays, some of which are listed here. Broadly, these features can be classified into two sets. One that enables the patterns like instance of switch expressions, etc. And another set, non-pattern related, like text block and others. In this talk, I will concentrate on features that are building blocks to enable patterns. Lambda expressions introduced a paradigm shift in programming, and that was not too long ago. Concept of patterns is already on the anvil. I would consider patterns as the next big wave in Java. So what's a pattern? The definition says it's a combination of a match predicate that determines if the pattern matches a target along with a set of pattern variables that are conditionally extracted if the pattern matches the target. Let us skip the textbook definition of patterns given here and take a step back from Java to understand the concept of patterns. Consider a text file, not a Java file, just a plain simple text file x.txt, which contains the following text. A journey of 1,000 miles begins with a single step. And let's say we are asked to find and replace miles with kilometers. You can initiate this by a find and replace dialog, or if you're a Unix or VI person, by the S command. Here we are more interested in conceptualizing what's going on internally. Let us say the editor has stored these words in a collection, an array or a list or something like that. Internally, the first thing it will do is to search for miles, search for the pattern miles, with the condition being element B equal to the pattern, or this condition what we call as the matching predicate. Once the element is found, it will return a pointer or a handle to that, which we call as pattern variable. See that this handle be need to be only conditionally extracted if and only if the pattern matches. Else, as a user, we are not really interested in that handle. And lastly, we invoke an action on the pattern variable, which in this case is set content to kilometers. So broadly speaking, this is the general way how the pattern flow occurs. Now let's try something concrete in Java and figure out how these concepts map to the new feature of instance of patterns.
Instance of patterns helps us to reduce traditional tedious boilerplate code and avoid redundancy by embracing the pattern matching concept. The pattern matching concept, which allows common logic in a program, namely the conditional extraction of components from objects, to be expressed more concisely and safely. Now, from this textbook definition, let's get to concrete code and figure out what exactly this means.
Consider the code on the left hand side. You can see that there are three things going on here. Number one, a test, which is O an instance of big X. Two, a conversion, which is a casting of O to big X. And three, the declaration of a new local variable X so that we can use the big X value without casting. This tedious error-prone boilerplate code can be reduced to a single construct, a single pattern instance of construct as shown on the right hand side. Let us break this up into the terms which we are familiar now. Number one, pattern. Here the pattern is big X. Two, matching predicate, which is the instance of check. Three, the pattern variable, which is X. And four, the action of is the body of the statement, which in this case is just the statement x.print. Remember that we said the pattern variable is extracted if and only if the matching predicate is true. Applying this logic here, we see that the local variable x is declared if and only if O is an instance of big X. Stressing the point, in other words, local variable x is non-existent if O is not an instance of big X. Let us explore this point a little more the coming slide. Consider the case where the if has an OR condition, which of course has two parts. The first part declares X using the instance of pattern. If the control comes to the second part, it means that the first condition was false. That is, instance of predicate is false, or in other words, O is not an instance of big X. Now we know that if O is not an instance of big X, then our pattern variable will not be defined and hence will be non-existent. Consequently, the compiler will flag the reference to X in the second part as an error, in fact as an unknown variable. Now what happens if we change the condition to an AND condition? In this case, if the control comes to the second part, it means that the first part evaluated to true. That is, O is an instance of big X, or in other words, the predicate is true and hence X is defined as a local variable, making compiler happy, which essentially means it's the right code. Mentioning that all this analysis is done during the compile time. What if we had multiple if statements with instance of patterns? As a natural progression of multiple if statements, we would expect to have a switch construct that recognizes the patterns in some way in its case labels. But that's quite involved, and what you see on the right hand side is a peek into the future. Well, that's not completely true. It's more of a mixed view of existing capabilities and those expected in the future. Java is constructing various building blocks for achieving this end. Let us start with one of the building blocks listed here, that is a switch that returns a value. Switch traditionally worked only as a statement, even though it is often more natural to express multi-way conditionals as expressions. Switch expressions remove this rigidity and hence the switch construct to yield a value. Moreover, this serves as one of the most important building blocks to support pattern matching. Switch expressions are a standard feature from Java 14 onwards. The code with the switch statement on the LHS can be transformed to that shown on the right hand side with the switch expression. The points to note here are: number one, switch can now yield a value. Two, the new arrow in the case statement. The arrow implies that whatever comes after the arrow represents a value for the switch expression. For example, the switch expression gets the value false if default is reached. Multi-constant case labels are more from a convenient and concise nature point of view. With the new yield statement, which we'll talk about in a few moments, the switch expression can be coded in a variety of ways. All of them are equivalent, but some are less concise, as shown as in the alternatives. You need to use the yield statement if you are using a colon to indicate that you are yielding a value. Again, even in a case label with arrow, if the RHS is a block, then yield statement is required. However, if it's just an expression on the RHS after an arrow, then yield is not required. Now, these are just nuances of the syntax, and we need not go deep at this point. At this point, the main takeaway is that the switch expressions are, after all, expressions. They can be used anywhere an expression is expected. For example, it can be as an expression for a return statement, or it can be a method parameter, or it can be even as an expression of a switch statement itself. Just wanted to stress the point that there is nothing special about switch expression. It is just another expression. Since switch expressions are expressions, that would mean that it should always yield a value, meaning it should always have a value. Now consider the case above where a switch expression is switching on enum color. So there are no case labels for blue or white. So what happens if X has a value blue? The switch expression doesn't have a clue what to return because it does not have a mapping for the pattern blue. It would not be able to yield a value. Now this is not allowed. It has to be exhaustive on the type of switching variable, and this will result in a compile time error. Hence, we need to add either a case statement for blue or white or a default case to make the switch expression exhaustive. Just recapping some of the features. A switch expression should have at least one result expression. For example, it's a compile time error to have a switch expression with empty block. Rightly so, because the switch expression is supposed to have a value at all times. It should also cover all the possibilities which we have just seen in the previous slide, that the switch should be exhaustive. The result should be compatible. If the switch is expected to have a string value, you cannot have a yield with an incompatible type. And you are not allowed to mix old and new. That is, if one case label has a colon, then all the rest of the case labels should also have colons. You cannot have an arrow case label mixed with a colon case label. Any discussion of switch expressions is incomplete without that of yield. A yield statement is a new construct in Java to yield a value for switch expressions. However, yield per se is not a keyword. It's a special identifier called restricted identifier. Yield has a special meaning only inside an yield statement. And remember that yield statements outside switch expressions are invalid anyway. This restricted identifier concept is not something new to us. If you remember, we did have an earlier encounter with such a construct, that is the var, which was a restricted identifier. Similarly, yield can also be used as a normal identifier in most places, and if your program has a variable named yield, it doesn't have to change when you move to Java 14. Only thing is, yield cannot be a type identifier. You cannot use yield for a type. For example, you cannot have a class called yield, and hence this is called a restricted identifier. Now comes an interesting problem. Let's say we have a method called yield. It takes an integer parameter and returns an integer parameter. Let's also say that we have a switch expression which switches on an integer and expects an integer back. Now we have yield 2 inside the case label in a switch expression. Now is this taken as a method call or a yield statement? Let's find out. Java resolves this conflict by imposing a rule. Unqualified yield statements are taken as yield statements. If you want it to be interpreted as a method call, then you should qualify yield either by this, if it's an instance method, or by the class, if it's a static method. Hence, the answer here is it's a yield statement. Just a quick recap about yield. Yield is a restricted identifier, essentially meaning that it can be used as a normal variable name, but it cannot be used as a type identifier. And yield statements has existence only inside a switch expression. Now let's move on to the next feature, records. See, often you hear people saying that Java is too verbose or it has too much ceremony, especially if you want to write classes that are nothing more than immutable data carriers for values. Or in other words, classes which has the only purpose of carrying some data to store some data. Properly writing a data carrier class involves a lot of low-level, repetitive, error-prone code like writing constructors, accessors, equals, etc. Now, records are intended to address this issue and provide an easy way by which the data carrier classes can be represented. Consider the following class entry. It has fields, it has a constructor, couple of accessors, and the routine methods. This is just a data carrier class if you look closely. With records, this entire code can be reduced to a one-liner code in Java. The Java compiler will put additional code for defining fields, constructor, accessors, and these routine low-level methods, thus reducing errors and unnecessary ceremony. A word about the syntax here. Similar to yield, the word record is a restricted identifier. It denotes a record only inside a record declaration. It can be freely used as a variable name anywhere else. Hence, there should not be any errors if you move to Java 15 unless if you have a type of name record, which is again unlikely if you follow the camel case conventions. Well, that's about syntax. Now, there is a difference from uh, earlier features to records. Unlike our earlier features, which had only language specification changes, records have changes in Java virtual machine specification as well. Now, this is not a surprise since the compiler is fabricating additional code here. So let's just take a quick look at what's going on inside. When you disassemble the bytecode generated from entry.java, you can see that it is in fact converted into a class, a finite class extending java.lang.record. This new class java.lang.record is a new class in JDK which has definitions for the low-level routines of hash code equals and toString. Unless you're dealing with bytecode analysis, you may not even have to know this part. Hence, I'm not planning to go deeper into these details, except of course mentioning that a couple of new attributes are added in virtual machine. The record attribute and the record component attribute to accommodate records. Record components are nothing but the parameters string name and int age in this case. These are called record components in the record parlance. Of course, we know that these components are internally converted to fields, private instance fields, and accessed only via the accessors. Record is in the second preview stage at Java 15 and expected to become a standard feature by Java 16 timeframe. Now let's move on to sealed types, which is a preview feature in the first stage in Java 15. Many a time, the purpose of a class hierarchy is to model the various possibilities that exist in a domain, such as the kinds of shapes supported by a graphics library, for example. In such cases, indiscriminate reuse is a bane rather than a boon. It helps the designer to model the classes very effectively if he knows what the class hierarchy is beforehand. When the class hierarchy is used in this way, restricting the set of subclasses can streamline the modeling. And sealed classes provide a very effective way to restrict the set of subclasses. Additionally, this also supports future directions and pattern matching by permitting the exhaustive analysis of patterns. Let us take a deeper look here. Let's say we have a class shape, and if we don't want anyone to reuse, then we can make this class final. But this is not our primary intention. Our primary intention is to make this class available for other two-dimensional shapes to extend. So we have to leave this class as a non-final class. But if this is a non-final class, then anyone can reuse this. So another option is to make shape a package private class. If we do that, the shape will not be accessible. Again, we don't want our class shape to be inaccessible. We want it to be accessible on the other hand, but we want it not to be extensible. Now that's where the sealed classes come in. Sealed classes provides more independence and flexibility to the class designer since the designer knows at the time of designing who all extends the class. That is, he has a complete class hierarchy picture at the time of designing. Consider the class shape which has seal modifier. It also has the permits clause permitting just two classes, circle and rectangle, to extend it. Rectangle in turn permits square to extend it. And here we have the class hierarchy. Now the important point here is this is the complete class hierarchy. Now if we try to add a class cuboid, for example, this will result in a compile time error since shape does not permit cuboid to extend it. It does not have cuboid in its permitted class list, to be precise. You can consider the sealed permits combination as something between a final and non-final class. From a pattern perspective, the most important point here is that this provides an exhaustive class hierarchy providing totality. Sealed classes like records have changes in virtual machine specification that is in the bytecode. Now let's just glance through the same. Consider the public class shape in shape.java which has a seal modifier and which permits circle and rectangle to extend shape. Now when we look at the disassembled snippet from shape.class, we can observe two things. Number one, though the modifiers are public and sealed in source code, in the bytecode only public is visible. JVM does not have a separate modifier for sealed. So how does it know whether a given class is sealed? Answer lies in the next point. That is, it defines a new attribute capturing permitted subclasses, that is circle and rectangle here. Presence of this attribute signals to the JVM that this indeed is a sealed class. Again, normal users need not be concerned about what's going on internally, mentioning here just for the completion's sake. Quickly recapping the features which we have covered: pattern instance of, switch expressions, record, and seal classes. Since we are used to Eclipse, let's figure out where in the big picture the compiler, that is the Eclipse compiler for Java or ECJ, fits in. ECJ is part of the Java Development Tools or JDT. What you see and feel are the features provided by Java Development Tools or JDT, your content assist, code refactorings, etc. There are a host of other tools, including Quick Assist, Hover, Disassembler, Null Analyzer, etc., to name a few. You might be familiar with quite a few of them. Additionally, the what you see and what you get feel is provided by JDT UI. All these stand tall on what we refer to as the three pillars of JDT, namely model, DOM, and search. Discussion of each of these pillars is out of scope for this talk, but noting that these pillars have their foundation firmly set on the Eclipse compiler for Java or ECJ, which implements the new Java language features which we have discussed in the talk. Well, thank you folks for being with me so far. Let me leave you with just one link where you can get more information. Whenever we implement the Java language features in Eclipse Java Development Tools, we create a wiki which lists different examples that bring out the features of the latest version of Java, that contains again correct programs as well as incorrect programs showing different errors. The link showed provides examples of Java 15 features. This should help you to get started with the Java 15 features. And thank you once again.